computer. Okay. All right. So how did those go? There were what? 6 of them?
I made it to 21, but I had got stuck.
Okay. And 21 might take a minute. It's a little bit harder than the rest. Did we get through the first 5?
Yeah.
Okay. Who's first? Jerry? Did you get these first 2?
The first 2?
Yeah.
Yeah.
So how
So for the first one, we were working backwards, right?
maybe.
That's
I mean, it's an equal sign. You can go either way.
well, it's an elementary edition. I did log base 2 parentheses A, and then plus log base 2 parentheses B. I'm not sure that was. Oh, okay.
Yeah. I wasn't sure what you meant by forwards or backwards, because technically we can go either way. We can expand it or we can condense it, right? And
Okay.
So
I was saying
this
backwards
one,
referring to the notes.
so this one they say expand the expression. I think it's instructions. So this one they're going to say expand, and then in the next few, like 33 through 53, those are the ones that we're combining. So we'll be going the other way, like when we hit like 33.
Okay. For number 8, do you put the? Oh wait, did I do this wrong?
Oh, that's Ellen. I messed up.
Oh, okay. For LN, do you put the base 10, or you don't have to, or is there a base 10?
So the base of LN is actually E.
Oh, okay.
Yeah, it's the opposite of E.
Okay. I did LN parentheses 3, and then plus LN parentheses X.
Yep, that's it.
I have a question.
Yeah.
Okay, I had got the same answer, but we put the parentheses on it kind of just to make it look better, right? Or you know what I'm saying? If that makes sense.
So I really like the parentheses. I guess you could probably maybe do that. But like when we start getting X plus 1 or something, I don't know whether that plus 1 is in the LN or not, right? And so when we start getting multiple terms, we really like need to get in the habit of putting parentheses around this.
Okay, gotcha.
I know some books will write them without. I don't think I will ever write it without. Like some books will probably put like LN of 3, but it's just one number. Or maybe LN of X. But even that starts to get confusing. Out of habit, I just like always put my parentheses. That way I know it's getting plugged into the log, right? This thing is getting plugged into the log. Any more questions on these 2? Okay. LN of 784. Oh. And who's next? Carson, are you getting these? Is Carson there? Jade, are you getting these?
I'm here. I'm just not understanding it as well as I'd hope right now.
Okay. So what do you see inside the log? What operation?
What are we on the 1n7a to the fourth power?
Yeah, number 9. Natural log of 7a to the 4th power.
Okay, I have the wrong paper pulled up then. Sorry. Is this the review? This isn't the final review, right?
This is the bookwork for 5.5.
Oh, I was on 5.6. That's why I was getting confused. Sorry, I'm pulling it up.
So if we see something like LN 7H to the 4th,
Sorry. I still don't see a 9 anywhere on here. I'm sorry. It just helps me if I can at least like have it pulled up in front of me. But
Here you go. Should be this worksheet, right? This one?
yeah, that's what I thought. Okay, both of those are wrong. Oh, found it. I was looking at the 5.3 through 5.5. Okay, 9. Is that LN or 1N?
That's Ellen.
Okay. 7A4. I have no idea. I have no idea what to do here.
All right, so what operation do you see in there? Like what's happening between that 7 and that A to the 4th?
Multiplication.
And if we have multiplication, what can I do with multiplication on the inside?
Oh, you can separate the two numbers that you're multiplying, right?
So I'm separating them, and what's the operation between them then?
What's the operation?
Between these two logs.
Oh, so dividing.
If you're multiplying, it's like a step behind. So if we're multiplying like bases, what do we do with the exponents?
Add them.
Yeah, so these are added. ln of 7 is just ln of 7. This is the thing that I have to use that other property on. So if we have something raised to a power inside my log, what can I do with that thing?
Move it.
To
Wait,
move
are you
it.
talking to the class?
Oh, yeah, that's fine.
I think
I
it's
was
going
asking
for
Jade.
IN.
Yeah, so the property is to move it down in front, right?
Yeah, yeah, for IN 7. Sorry,
So we get something like the natural log of 7 plus 4, the natural log of A. And that is fully expanded, right? I'm not going to get anything else out of ln of 7. I'm not going to get anything else out of what, 4 ln or ln of A. We have ln and basically one number. What? You begging me for treats again? Gosh, get out of here. My dog bullies me until I give her treats. All right, and then we have stop. I want to share. Let me just share a whiteboard.
This me teacher here, the answer for number 9 is going to be for IN 7 plus for IN A, right? Like we move 4 to the in front of IN. Down, right? That's what I did.
ln of 7a to the 4th is what we had, right?
Yes.
So the ln of 7 plus ln of a to the 4th is the next step. And so the final thing is that we're going to move that 4 down in front. That 4 gets moved down in front of the ln of a.
Yeah, okay, yeah, only. Yeah.
Yeah, it doesn't get moved in front of the other one.
Okay, thank you.
Only the log gets attached to.
Okay, before we go to the next, I just have I always got a question.
Mhm.
I thought I'm trying to double check. We don't move the exponent for we don't move that one first, like move it over to the L, in front of the LN. We
Like
don't,
that?
yeah, and then bring down. I mean, like,
So this goes back to your exponents. What exponent is on that 7?
A.
No, like
It's
just
1.
I mean,
yeah, there's only an exponent of 1 here. So that exponent of 4 is only on that A.
okay.
Yeah, glad you asked. I guarantee you someone else was looking at that same thing. Just didn't want to say it. Okay, that was which one? 9? 10 says log of a to the 3rd over 3. Got to do a pen and not eraser to write things. Log of 8 to the 3rd over 3. That's a horribly drawn 3. All right, who's next? JD Dancer, Josh.
So it turns the a to the 3rd into 3 log a minus log 3.
Yeah, okay, so you did that in 2 steps. I'm going to break it apart. Or you did it in 1 step. I'm going to break it apart into 2. So the first thing that he noticed was like this has some division in it. So he took care of the division. He separated the logs, made the division into subtraction. And so we get log of 8 to the 3rd is the numerator. And we're subtracting the denominator, which is 3 or log 3. The other thing he did was notice this thing has an exponent of 3. So he brought that 3 down in front, said 3 log a minus the log of 3. And so we get log of a single term, log of a single term. That's a pretty good indicator you've fully expanded it. Can we combine log a and log 3? I guess that's the other thing people try to do.
No.
Yeah.
No.
Unless it's exactly the same thing in the log, we can't combine logs, right?
If we have
Maybe-
the same base.
Yeah, if you have like a log 2 plus what, maybe like what, 3 log 2? You could probably
Yes.
combine something like that. You have 4 log 2s, right? Only if it's exactly like the same thing. It works sort of like terms. If you wanted to call this x and you wanted to call this x, you would have 4 x's, right? Okay. Log. Oh man, this one's almost easier than the previous one. I think we did probably enough like this. Log of 6 over z. It's subtraction,
Like z
or
minus
it's
log.
division, so it should be subtraction.
Yeah.
So log 6 minus log z is what you should be getting on that one.
Yes.
Did anybody get 21?
Okay.
Kind of.
Kind of.
Yeah.
Yeah.
I'm not sure if I did it right.
Y squared. Ooh, that one's a little tricky because we hadn't really talked about like what those things look like.
Here it's the subtraction picture, right? We subtract and then we move the exponent down.
But the exponents on what radicals, we hadn't really gone into depth about that. We used to go in more into depth in this class
Like the
about
cube.
those sorts of things. So this is y squared. If I want to write z,
Power of 1 over 3.
this is a square root. How do I write that with the power? That might help us.
2 over 3.
Ah,
3 over 2.
it should be the other way around. 3 over 2. Yeah, that's it.
3 over 2. Yeah, yes.
And I think we talked about it like square roots, you can look at like half powers, right? So if I have, oh, that's not what I want to do. I'll move this around because it's in my way. If I have like a to, or let me do square root of a. This is a to the 1/2 power. You can look at square roots being like a half power. And so we have z to the 3rd to the 1/2. We're multiplying these two things. And so this is sort of like we have a z to the 3/2. Okay. And if we do that, this is ln of what you said, x to the 4th. So someone already told me that we have subtraction. So it should be the numerator. subtracted by the denominator. So I should start out with ln of x to the fourth, and I should be subtracting ln of
Y squared, no, x squared, square root of z 3 of 2.
so it should be y squared. Y squared z to the 3 halves. That's it.
X, Y, yeah, sorry. It's not X, sorry.
Okay.
Teacher, I have a question, please.
Yeah, go ahead.
Here, thank you. Here, do we need to write down like the exponent? For example, we have in x of 4. It's going to be 4 in of x minus
That's the next step I
yeah,
was about
minus
to go
2
into.
y minus 2 in of y square root. It's not the third one, the z 3 of 2.
Yeah, I was about to like
Ah,
bring this. Yeah, that's gonna be one of the next steps I take. We want to bring stuff down in front. Before we do that, though, I want to look at that second term. So I can break this apart.
mhm.
That's still ln of x to the fourth. I can break this thing apart as ln of what?
Y squared plus
And
z.
then in parentheses, it'd be z 3 over 2.
Yep. So that's ln of y squared. That is ln of z to the 3 halves. And what about this thing? What should I do? This is one of the things I think will probably trip some people up.
Do you need your brackets?
I gotta, yeah, brackets, parentheses, something around.
Sorry.
Yeah, so this is 2 ln of y should be the first thing. And if I drop my parentheses, I'm distributing this thing. So this thing should also be subtraction. And so if this is ln of z to the 3 halves, how can I rewrite that?
It was the 3 halves.
3 halves ln z. Questions about this one?
Is that the final, like, that's the answer?
Yeah, because we got ln of x, ln of y, and ln of z. So we're not going to be able to simplify anything else out of
I did mine different, but I got the same answer.
there. If you got the same answer, there's a good chance you did things correctly again.
I just did everything, and then at the end, before we like finish, that's when I started working on the square root of z.
Oh, when you brought it down in front?
Yeah, I
Yeah.
did that at the end.
Yeah, it sounds like you did it right. Okay, so the other thing, what was I going to say? It's on bottom, usually you're subtracting it, right? These are both in your denominator. They should probably have subtractions in front of them. It's one of those things you notice after you do these for like 12 years. Any more questions on these? We got a few more problems to work. Which ones did they assign? 39, 49? I'm going to share just the screen then. It looks like we're assigned 39, 49, and 53 from these. 39, 49, and 53. Those are the next three I want to do. I'm going to throw in maybe like 3 more. Let's do 36. I'll type it in the chat. 36 looks good. 39 looks good. What was it? 49 is
Teacher, please, before we put us in the breakout room, I have another question, please.
and 53.
He-
All right.
Can I
Oh.
ask?
Yeah, go ahead.
Thank you. About here, just what we did right now. For the first part, it's okay. But why in the second part you did like the subtraction in the denominator? Because if it's the denominator, okay, we have
For which one?
for just what we did right now, the 21.
Okay.
Okay, the first part is okay for nx, it's okay but for the second parts we have like in y squared times z of 3 of 2. You mean because if it's the multiplication we are going to subtract them?
The
Again.
division is where the subtraction comes in. We're subtracting everything that's within the denominator, which is y squared z to the 3/2.
Yes.
And so when we expand this second term over here,
Mm-hmm.
this thing expands as addition, right?
Okay.
But this entire term thing here, ooh, I forgot my ln here. Ln of z to the 3/2. This entire term, this ln of y squared plus ln of z to the 3/2, this entire thing has to get subtracted. Because we're subtracting the denominator, and this thing that we just expanded was from the denominator.
Okay. Thank you. Because I was confused a little bit here and I'm not sure. Thank you.
Yeah, that's a tricky step, like realizing that, hey, you just expanded the thing in the denominator and that entire thing was getting subtracted. And I think that's probably going to be like one of the most common things that people get wrong. They're going to tell me ln of x to the 4th. They're probably going to tell me minus this first thing. Don't do this. Please don't do this.
It's what they did. For this one, I want some more explanation here.
They're
Thank you.
probably going to end up dropping those parentheses and not getting a negative z to the 3/2, right? And that's going to change. That's going to change your answer. So let me do a big red. Don't do this. Don't do that.
Thank
Don't do
you.
that.
Thanks so much.
That's probably one of the most common mistakes I'll probably see on this problem when people work through it.
Okay. Thank you.
After you teach math for a few years, you know exactly where people are going to fall usually. There's this common pitfalls that people do, and you try to address them. Any more questions? I think I sent it. Ooh, I sent it to waiting room participants. Weird. Glad you sent it out. Okay. We're opening the break rooms.
Yeah.
Opening break rooms now. So I want to work on those few problems, come back. Why is it going to waiting room participants? I gotta pause recording too. Recording again. Before we go into condensing these things, I want to do one more expansion problem. So I just came up with this problem. So if we have something like log of x in the square root of z plus 3, I went ahead and made this a exponent of 1/2. So this is the same thing as saying what log of x and the z plus 3 is to the 1/2 power. So how would I expand something like this?
I think it's because here it's the multiplication, it's going to be subtraction. Like x
Multiplication is what?
minus. It's going to, we can go into write it as log x minus log minus 1/2 log z plus d. What do you have there? I don't know. Z plus 3 something.
If it's multiplication, what do I change it to?
Addition.
Oops.
Should be addition. Yes, yes. Log of z plus 3 to the half power.
Mhm.
And this one is log x.
Plus.
And so this is something like log x. And I think you told me, were telling me to bring the power down. Is that what you're saying?
Mhm.
Is the next thing, is the next rule that we can use. 1/2 log of z plus 3. And I'm looking at this. What else can I do to this? Can I do anything to this? This is kind of why I wanted to go for it.
No, you can't do
No.
anything else.
A lot of
No.
people look at like that log of z plus 3 and they really want to do something with that z plus 3. Whoop.
No.
That is it. If it's multiplication inside the log, we can add on the outside. That's the rule. So if we have addition inside the log, just keep it as addition inside the log. There's something pretty similar in your homework, so I was making sure we get something similar to that. Questions about this one? I know I just threw it at you, and it's not in the book. Okay. So the multiplication becomes what? Addition. Multiplication inside the log is addition outside the log. And then I bring my power down. Okay. And the next one, let me grab this little chat here. 36 was the next one I had. So if we do something like ln of 33. Whoa. I did not do that. That was a glitch. 33 minus ln of what, 11? How do I combine something like this?
Divide.
Divide.
As a
Okay.
fraction, the 33 and 11 as a fraction, right?
So I'm doing ln of what?
33 over 11.
33 over 11. And if I want to simplify that, that's ln of
3.
3. So we went one way to expand it. Now we're using all the same properties. We're going the other way. So sometimes you will hear like equalities expressed as a biconditional statement. One way to maybe explain it. We can go either way.
I have a question. We will only change that into a decimal if the problem asks us to.
Yeah, what does it say on here? I know it says different things in different parts. It's like combine expression by writing them together as a single log expression. Yeah, if we had to approximate this, you could, I guess, plug it into your calculator, give me a decimal expansion, but they just want it as a single log. In the math class, we really like to write things like as precise as possible. And so if you do like a decimal expression, you're approximating, right? This would give you an exact solution here. Sometimes we need to approximate, like if your boss asks you how long is this thing and you tell him ln of 3, he's gonna slap you, right? He's gonna be like, what the heck are you talking about? Give me a number, right? So sometimes if we're doing word problems and we have to plug these things in, we definitely want to evaluate them. That was 36. The next one I did was what, 39? So log 4 plus log 3 minus log 2. All right. Fidel, did you get this one?
Yes, I did.
All right. So what is the first thing you combine?
So what I did, I put the 4 times 3 over 2.
Oh, you did it all at
then-
once, huh?
Yeah, then I
That's it. We get log.
Then I canceled out.
That's it. It's the same thing. You just combine these all in one step. I was just trying to write it out in
Right.
different steps. So we're multiplying the first two. We're dividing that last one. And so what'd you
Yeah.
get overall?
Log of 6.
Log of 6. That's it. Any questions about this one?
You mean he multiplied 4 times 3, which is 12. 12 over 2 is 6. Yes.
Huh? Yeah, so we're multiplying the 4 and the 3 to get 12. We're dividing by that 2 to get 6.
Yeah.
And this was what, 39? The next one I assigned was what, 47? Ooh, they get a little bit harder as we go on, don't they? 3 ln of x minus 3 halves ln of y.
Which one, please?
47, 3 ln of x minus 3 halves ln of y plus 4 ln of z. Who's next? Kayla? Did you get this one? No. Vanessa, did you get this one?
No, I didn't understand this one or how to start it.
So we're working backwards. When we were doing the expansion, the last thing we did was bring the exponents down in front. So now that we're working backwards, that's the sort of property we want to start with. So now instead of being down in front, I want to write this as ln of what? X to the
Third.
Right in the class.
I was asking Vanessa if she got this.
So you're combining it, you're saying?
So this is the exponent rules. Instead of having an when we're doing it expanding, we brought the exponent down in front of the log. And so now we want to take things that are down in front of the log and raise them up to the exponent.
So would the 3 over 2 be raised by the y?
Yeah, so that the y is raised to the 3 over 2. And the last one is I have ln of z to the what power?
To the 4?
Yeah, that's it. Okay. My advice is to take these things kind of 2 at a time. If I look at these 2 things, how do I combine them?
Hint.
What's the operation?
Would it be x and would it be subtracted from each other?
They're subtracted already right here. When I combine them to the same log, what is the operation in the log?
Multiplying?
The other one. It would be multiplying if they were added. If they're subtracted, it's what?
Dividing?
Dividing. I feel like these are SAT, like, do you ever take those SAT analogy sort of problems, right? You know what I'm talking about? This is the that is to this or whatever. It's like adding is to multiplying as subtraction is to dividing. All right, x to the third and y to the 3 halves on bottom. And I still have plus ln of z to the 4th. I might have to delete some stuff right on top. Questions so far? Are we getting these?
Yeah.
All right, so now I see this thing. And I see plus ln of z to the 4th. So I think we're almost there. I have an x to the third, and I have a y to the 3/2. I don't know how picky Miss Wise is going to be. But if you did y to the 3/2, that's fine for me. If you're doing y to the third square root, that would also be the same thing. I know we didn't really go into great detail on like fractional powers. We used to go into a bit bigger detail on them. What about this ln of z to the fourth? How do I combine this? Where's that z to the fourth going?
It'd be subtracted.
It's being added. So what does addition become when I put it inside the log?
Multiplying.
I'm multiplying by z to the fourth. So if I multiply this fraction by z to the fourth, where's that z to the fourth going? On top or bottom?
Be top.
Yeah, it'd be top. I'm basically multiplying by the z to the fourth over 1. When I multiply things, they usually go to the top of the fraction. If it's a whole number, right? Anything else I can do with this? Got this thing right here. I'm looking at it. It looks like everything is within one log. That's basically what they asked me to do, right? Did y'all get that one? That one's a little bit more complicated than the rest.
Yeah.
It's got some steps to it.
I end up the z to the fourth. I put it on the bottom. I thought it always go to the bottom, but now I know it always goes to the top.
If this was minus, it would go to the bottom, right? We'd be dividing by z to the fourth.
If your answer, if the y is in like a square root, is that okay?
Yeah, if you do the square root of y to the third, that's fine. It's the same thing. I think that's probably what it's going to be in the back of the book. They're probably going to convert stuff to radicals. I'm not going to be that picky if I grade stuff on it because I know we didn't go into great detail onto like fractional powers and radicals. But you should know sort of how to convert that with square roots. So we get ln x to the third, z to the fourth on top, and y to the 3/2 on bottom. Questions about this one? Okay. And I want to do which one? 49 is next. ln 1 over e squared plus 2 plus ln of 2e. And that is what, 49? And who's next on my list? Ashley, did you get this one?
No, I didn't, but we could start on it.
Yeah, sure. So if I want to combine these to one log, what does it look like?
It would be multiplication.
Yes, I do 1e squared, and I'm
Um,
multiplying by 2e.
yes. Okay.
Excuse me, which number, please?
This is 49.
Oh, yes, thank you.
So ln of 1 over e squared plus ln of 2e.
Would I put 2e over 1? Would I do that?
So the 2e is going on top, and what's going on bottom?
With e squared.
E squared should be on bottom, yep.
Mommy?
You can simplify this how?
You could take an e out, right?
Yep. And so that e is no longer there. This one gets dropped by a power.
And it'd be 2 over e, right?
Yep, that's it. I was trying to think. I think we did this yesterday, doing ln of 1 over e.
It the L if I'm not mistaken, the L, yeah, it'll cross it out and it'll leave it. No, right?
Yeah, you get -1 because it's e to the -1. Yeah. That doesn't work so well on this one though, right? With that 2 up there, that 2 changes things. So I don't know if that was something that might have like tempted y'all to do something there.
Yeah, because when as we were just right doing it, I was about to say what I always think when I had to when we could cross it out is 1, but for some reason I always forget my negative sign at first. But that's what I was about to say. Hey, it's, it's 1 with -1.
Yeah, so I mean, these are good ways to like maybe solve it. It's just kind of like we want to go with what their instructions say, and they want us to write it as a single log. So they wanted us to use the log properties like we did here, right? But if you're looking at this and you said, oh, that looks like a -1 or something, I wouldn't like disagree with that, right? This looks like a -2 here, right? But that doesn't help us write it as a single log. So it's kind of knowing what they're looking for, kind of the fact that I've done this for 12 years nonstop or something like that. I think it's been more than 12. I think it's 15 now, probably. When you get old, you don't realize how long time periods are anymore. ln of 2e, that's not so easy to simplify out, right? We can't just simplify out the e because it's got a 2 attached. And this is the thing that really trips it up, I think, with being able to evaluate the log by hand. Questions about this? So that's what they wanted, right? ln of 2 over e should be your final thing. Okay. And that was 49. The other one I signed, I think there's one more I signed. Where is it in the chat? 53, the last one. Oop, gotta write it down. Log of 4 minus log of x plus 7 log root x. Okay, next, Ganya. Did you get this one?
No, we didn't, but I will try to do it now. Here we have log 4 minus log x.
Did anybody else get this, or should I give you a little more time on this one?
I kind of did it. I did mine.
I feel like I'm going to give you a little more time on this. I'll ask you again when we come back.
I'm kind of confused on the square root of, or the 7 log the square root of x part. I'm just having trouble like putting that together.
I think I'm not really sure what direction I have to look and do this problem, to be honest. But if you do x to the 7 halves, or you do what? Square root of x to the 7?
Yeah.
Or even if you did this and then to the 7th, I guess that would be correct too. That's a little bit less desirable though. Doesn't look
Would that,
as clean.
so that's where I ended up, but would that be like the end of it, or would you, or, never mind,
These 3 things are all kind of like the same way to write the same thing.
yeah.
When you evaluate x, you're going to raise it to the 7th power and you're going to square root it, basically. Or you could do it all in your calculator and just do it to the 7/2 power. Yeah, we didn't do fractional exponents. We skipped past that. We used to do that in this class.
If we have time, when we're done, could you show us how to use logs on our calculator?
Yeah, sure. That might also depend upon your calculator. I know some of them do the change of base already and some of them don't.
I think mine has it, but I don't know how to change the base.
All right, so we'll go past those. We're going to do 53. 67 is going to take you a minute to probably think about. And what else? 75 was assigned. 77 was assigned. I feel like no, all these are going to take 1 second. We're going to do all those. So this is a calculator check problem, basically. Do a change of base. I guess you got to know the change of base formula, but that's probably the easiest formula we learned in this section. So doing change of base, doing composition of functions. See, I really wouldn't try to be just a jerk by telling you this stuff is going to come up again and again, but like this class builds on itself, right? And now we're going back and we're doing stuff that we did already. So 5367, I'm going to give you all a few minutes and open up the rooms. If there's any questions, speak now or forever hold your peace. All right, I'm going to open up rooms and we'll finish this off.